Now, we discussed why this idea of moles, or N, is really important for this equation. So how are we going to figure out the moles if we have these other values? Well, we just mentioned on the computer, we're going to be able to figure out the pressure of this current room. I can easily look up the temperature of this room, again, going right to the weather channel. And I can also take it currently in this room as is. One of the things that I'm doing that we'll do at the end of the lab is right now I have a balloon at room temperature here, and I have a balloon actually outside at this moment. To put in perspective, currently outside I am seeing that the temperature is negative 14 degrees Celsius, which again I can convert to Fahrenheit for everybody. But again, we have to be extremely careful with that, because as everyone knows, can we use Fahrenheit or Celsius with this stuff? The answer is no. Both of these scales can go negative. And if you get a negative value here, that's positive, that has to be positive, because amount, you can't have a negative amount of something. You either have it or you don't. So if this is negative, this whole thing is negative, which means one of these is negative. And negative P and negative V don't exist. You can't have negative pressure and you can't have negative volume. You can't negatively push on something and you can't take up negative space. So again, the most important thing that we remember is when you're taking the temperature, we need to convert to Kelvin. The joke is, if you use Fahrenheit, that's your grade on this lab. If you use Celsius, that's your grade on this lab. You want to do OK. Make sure everything's in Kelvin. Going back to this, how are we going to be able to figure out the last piece, which is the volume? I can look that up, I can look that up, I have this is our variable, I need the volume. What we can do is, we can actually have a set amount of Alka-Seltzer, half a tablet, 1 tablet, or 2 tablets, which I'm going to add to 9 milliliters of water. Each of these has 9 milliliters of water. As I put these in, I'm going to put a balloon over it as quickly as I can and let it go till completion. So if you don't know what Alka-Seltzer does in water, it's going to break down. This helps with heartburn, things like that. So it's very quick how it reacts. So to speed it up even more, I'm going to crush each of these to allow it to go faster. Once I do that, I'll put each of them on, do them one at a time, using 3 different balloons, just because if this stretches out, I don't want that to impact the other 2. And we'll see how big those balloons are. After we see how big the balloons are, we can actually use 2 equations to figure out the volume. First off, I can do my best to make the balloons a sphere. And if we know it's a sphere, that means if you cut it right through the middle, that's a circle. Well, the circumference is 2 pi r, and we need the r, radius, for the volume equation of a sphere. This is a very bad sphere. It looks like a smiley face. And that equation is, of course, 4/3 pi r cubed. These equations will be into the form for everybody as well. Again, not perfect, but we can do our best, and we have a measuring tape which we'll do together for that. So, once we have the volume, we'll have the pressure, we'll have the volume, we don't know N, we have R, we have T, and we'll go from there. As you can see, already done.